Hi, in this video we're going to look at common types of different process in thermodynamics. Process is described the transformation from one state to another. For example, I have state 1 that has one particular pressure, P1, and T1. Realize those are intensive property, right? Does not change with the mass. And then state 2 then might be completely different pressure and temperature. And if we were trying to describe this in a PT diagram, pressure temperature diagram, this could be my P1, T1, and let's see, my T2 and P2 could be here. Okay, so when you describe the state 1 and the state 2, you want to go from here to here. There are many ways to get there, right? Just like many roads leads to Rome, there are many ways go from state 1 to state 2. For example, here, I could go straight line, okay? Also, I could go constant pressure. The reason I call constant pressure because pressure here is the same, right? Well, I can go constant pressure, getting to this point, and then I can go constant temperature up. That could be another way also. Then you start to getting the message. I can go many different ways. Another way I could go this way. I could go constant temperature because it's at the same temperature here, and then going constant pressure back to 2. So we just demonstrated 3 already, and there are many other ways. For example, we could go this way, parabola. So there are many different processes going from one to the other. In order to describe this process, those are common ones. The first one is called isobaric. Iso means the same, right? In Latin means the same, which means a constant. Isobaric one bar is about 100,000 Pascal, so that's a pressure unit. So means constant pressure. Isobaric. So for example, this process is going to be constant pressure, right? Isobaric. And then we can call isothermal. Thermal means heat, means a temperature. Isothermal means the same temperature. So for example, this will be isothermal, same temperature process. Then we have isochoric. Choric or can call isometric, means same volume, constant volume process. Okay, and then you can call isentropic. Entropy, we're gonna learn that later on. It's S. Entropy, iso means constant entropy. That could be a process as well. Then it could be adiabatic. Adiabatic means no heat transfer. So all the above here, it's all iso, means the same. Adiabatic is something you just need to remember. It's no heat transfer. To describe that in mathematical equation, Q here in thermo is considered as heat, so it means heat transfer is 0. So whenever you see something in the problem that says it's adiabatic, you know Q equal to 0. Heat transfer is 0. When you see constant pressure, that means pressure. P1 is equal to P2. It's a constant. When you see isothermal, T1 is equal to T2. It's constant temperature. And isochoric, constant volume. V1 is equal to V2, a constant. Isentropic, which means S1 equal to S2. That's a constant. All right, hopefully this helped you. Because later on in thermo, when they tell us in the problem or when you make assumption on those process, those are the condition we'll be using. All right, I'll see you next time. Bye.